Okay, so video one was about dilations and then just finishing the final details of dilations. But now we're going to be working about similarity. And this is the opposite of congruency. So I'm going to go over congruency again and I'm going to compare that with similarity. I found this really interesting image in here where it says, we are so similar. Yes, they are similar. They are similar triangles. They have corresponding angles are congruent, but they are different size. So that can tell you what the difference between similarity and the other term, the congruency, is. And then we have in here another, it has to be the exact same angle. And then it's like kind of funny. I'm sorry, Bob, but I'm still looking for Mr. Right. So this 91 degrees in here, it's not enough to say that these two triangles are congruent because it's not the same angle. So they are not similar for sure. Now, we're going to move on and we're going to go over similarity versus congruency. Well, so the symbol for congruency, and I hope I'm not covering this section in here, the symbol for congruency is a symbol that you have in there. It's like a wave with the two lines. That means that the figure have the same shape and the same size. So we have in here, for example, triangle ABC and triangle PQR are congruent because they have the same shape and they have the same size. So I would say triangle ABC, it is congruent to triangle PQR. And notice how A and P are corresponding, B and Q are corresponding, and C and R are corresponding. That's what you worked on week 3. Now, similarity means that they have the same shape, but the size is different. So let's assume in here that this angle, I'm just going to modify this a little bit. Let's assume that this angle, even though in the figure it's pretty obvious they are not, let's assume that these angles are the same and these two angles are the same, and let's assume these angles are the same. Okay? If that happens, so you have the same angles but the figure is bigger, then we say that they are similar. So here we have then triangle A, B, and C. It is similar to triangle PQR, okay? Because they are the same shape, but they have different sizes. So if you notice here, when do we get these figures in here, the congruent figures? When we have rigid transformations. So when we have translations, rotations, or reflections. When do we get different shapes that are different sizes? Dilations. So when you do dilations, the figures obtained are similar. When you do reflections, rotations, or translation, the figure obtained is congruent. Let's see a few examples in here. It's a really short video. Is it the same shape? Yes, they are the same shape. Do they have different same size? No. That means that these two figures are similar. Okay, here, do we have the same shape? Yes, a perfect circle. Are they the same size? No, they are not the same size. That means they are similar. Here we have these two like moons. They are similar or congruent? They have the same size? Yes. Are they the same shape? Yes. So they are congruent. And here, notice that this figure is rotated, but that doesn't mean that it is the same size. So the figure, this last example, it is a dilation and a rotation. Do they have the same size? No. Is it the same shape? Yes. That means that they are similar. And that's all what it is. Now I'm just gonna go quickly over what you have to do next. Remember, yellow background means that you have to do something, there's some work in it. You have a Google form where you have to identify and tell me if they are congruent, similar, or neither. Just wanted to mention in here that I changed my tutoring hours. Instead of doing for second and fifth period at 11 a.m., from now on, I'm gonna move that to 10:15 a.m. So just keep that in mind. I will post a reminder in Google Classroom as well. And that's all for this week. Hope you understand. Please let us know if you have any questions, and that's it.